Hello everyone and welcome back to Life Technologies YouTube channel. I hope you're having a good day and thank you so much for watching this episode. So this is another session of our Huawei Lab simulation series, and in this session we are discussing a very interesting topic of how to use AS path filters to control route advertisement on Huawei routing devices. So you know that BGP, that is a very common protocol and it's deployed on many service provider networks. And the best benefit of having BGP is that it gives you the control or the flexibility to control how traffic can flow on your network. So BGP depends on many path attributes. We have things like the local preference, the weight, MED, and many other path attributes that are used in BGP. But one of the common and the most used attribute is the AS path. So this AS path attribute can be used for route selection, and it's also used for controlling or preventing loops in a network. So whenever you are advertising a route, you know that with the BGP route advertisement rules, when you advertise a route to an eBGP or an external BGP, then you need to append your own AS path. So you must add that AS path number of your local AS. But if it's iBGP, then we don't add the AS path. So once you receive some routes in BGP, it will be having a list of AS path indicating that this route came from this autonomous system number, it passed through this autonomous system number, and now it's in my AS. So when I advertise the route to another autonomous system number, I will also add my own AS number. And that is how it works. So with this AS path information, we can do some filters. The same way we use IP prefixes to filter some IP prefixes and control whether they should be advertised, whether we can change some parameters. We can also do the same. We can use AS path attribute to filter some routes. Maybe we don't want some routes to be advertised to a given AS. We don't want some routes to be advertised to us. We can use AS path filters to do that functionality. And of course, when we do the filters, many times we are using the regular expressions. So regular expressions, if you have done some programming, you will know that these are special, like kind of you can have, you know that when you have the AS path list, maybe you just want some routes that come from a given AS, you can have a regular expression to represent that. You have some routes that are passing through some autonomous system number, you can have a regular expression to do that. So these are some kind of representation that you can use to ensure that you are able to match the specific AS numbers. Either it's coming from an AS number, either it's traversing through some AS number. You can use regular expressions to achieve that functionality. So that's what we'll be focusing on in this session, just to show you how you can use AS path filters and regular expressions to control how routes are advertised across the network when you are running BGP on a network. So before we dive into the lab, of course, you can see that this is the topology. You have router 1, router 2, router 3, router 4, and router 5. If I show you the topology so that you can see the AS numbers assigned, so these are the different router that we have. You can see that R1 is in 65001, R2 will be 65002, R5 is 65005, and then we'll be configuring the loopback IPs, and those loopback IPs will be advertised into BGP, and then we can verify the route information that we have on these different routers. We'll be using mainly router 1 to prove the concept of using AS path filters to control route advertisement. And then on R4, we'll also be doing one scenario to show you how you can use AS path filters to control how routes are exported from one AS to the other. On R1, we'll be focusing on import. When you receive these routes, you either accept them or you reject them. So this is the topology that we are using. and we'll be having different scenarios. So before we jump into configurations, just a kind request that if you are watching this video but you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming videos. Also remember to like, comment, and share this video with your connections. So to the lab configuration steps, of course, as usual, we need to do the basic configurations. So we need to configure the interfaces. We've done this multiple times, so I won't be explaining a lot about it. I'll just go ahead and do the configurations so that we will be going ahead and doing the configurations for the regular expressions. So if you do the configuration, again, you need to do a commit. That is for R1. R2, we also need to do the same. So we are configuring loopback 0 that will be used to simulate some networks. So I'll do commit on R2. Then on R3, we'll do the same. Commit. On R4, we also do the configurations for the interface parameters and the host name. Then finally on R5, we only have the loopback interface and the interface towards R3. So this is R5. I'll do the configurations and commit. Let's confirm we've done a commit on R4. Yes, we've done the commit. So for the basic configuration, very straightforward, very easy to understand. We've done this multiple times. Maybe if you've missed some of the configuration commands, maybe you don't understand some of these commands, just feel free to reach out in the comment section and we will explain them to you, or you can check our previous episodes on this series. And then step 2, we need to configure the eBGP peering between the routers. So again, we are configuring BGP sessions between different routers. So R1 will be peering to R2 and R4. As you see, all these connections will be having iBGP peering sessions. So we have a session, if I have a pen somewhere. So we establishing BGP sessions from here. We should have a session to R4 and R2. R4 should be peering to R3, R2 and R1. Same to R2 should peer to R3, R1 and R4. R3 will also have 3 sessions to R5, R4 and R2, and then R5 will only have 1 session towards R3. So these are the sessions that we'll be having, and all of them will be eBGP peering sessions. So these are the BGP configurations. Also very straightforward, very easy to understand. If you haven't done this lab on BGP configurations, we have multiple sessions on this series that are explaining how to implement BGP, how to use BGP attributes, and many other lab simulations that are using BGP. Because remember, BGP is a protocol that you will not avoid if you are a network engineer working in a production network. You will have to deploy BGP, you will have to troubleshoot BGP. So you need to understand these basic commands and know how BGP works, the working principle of BGP. So starting with R1, we are configuring the router ID and we are establishing the BGP peering sessions towards our neighbors. So all of them are eBGP sessions. So you need to ensure that you configure the correct AS number. And then when you are configuring the peer, you also need to ensure that you specify the correct AS number, and then the peering session should be able to come up. So let's do the configuration starting with R1. We go back to R1, do the configurations, and again we need to commit. On R2, we'll do the same. On R3, On R4, we do the BGP configurations and commit. And finally on R5, so once we've done the BGP configurations, we can verify the BGP peering sessions. And these are the commands that you can use. Display BGP, actually these ones should not be here. Display BGP peer. So you can display BGP peer to check the neighbor relationship and it should be in established state. You can display the BGP routing table. You can check the advertised and received routes on different routers. But first, let's confirm the BGP peering session. So display on this router, I need to display BGP peer. So you see that we have sessions here. Again, you need to verify that all the sessions are up on the different routers. So you see that R2 has 3 peering sessions and they are both in established state. We don't have any prefixes received from the routers because we've not advertised the loopback IPs. So we'll go ahead and do that. If you display BGP routing table, you will see that we don't have any routes available on the routing table. So one thing that we need to do is we need to use the network command to advertise these routes. So 65001, I'll do network 1.1.1.1, mask is 32 and commit. I'll go ahead on R2. So this is BGP 65002. I'll use the network command and advertise the loopback interface into BGP. On R3, we will do the same. So it's BGP 65003. We will do network command 3.3.3, mask is 32 and commit. On R4, we'll do the same. BGP 65004. Use the network command 4.4.4, mask is 32 and commit. On R5, BGP 65005, you use the network command 5.5.5, 32, and then you do a commit. So once you've committed, now we can go ahead and check the display BGP routing table. So when you display BGP routing table, you see that we are getting routes on this router, and what we are focusing on is on the AS path list. So you see that the information is coming in and it's coming in with the AS path information. So for example, 5.5.5.5, it's coming from, this is the origin AS, the source autonomous system number that this route originated from. You can see that 2.2.2, it's originating from this AS number 65002, and we are also getting one route from 65004. So we have a direct route and then there is one that is coming in from the other peer. So these autonomous system number, we can use them using the AS path filter to control the route receiving and advertisement on these routers. So this is what we'll be doing in this session. So again, I mentioned that we'll be using regular expressions. So some of the common regular expressions that you expect to see, for example, if you see this caret 64513, this one, you see that it will be matching the AS path that starts with AS 645113. So if the AS path is starting with 645113, it will be matching this regular expression. The second regular expression will be matching any AS that ends with, so that dollar sign will be ending, the and sign or the dollar sign will be ending with 64513. So it will be checking the AS path and then it will compare with your regular expression and it will be able to make a decision or perform the action that you've specified. So there are different ways in which you can use AS path filter. You can either use them directly once you've configured, or you can configure a route policy. In this session, we'll be just using the them directly. You configure them and then you apply them directly without route policy. But many times it's always recommended that you should be using route policies. So in a later session, we will demonstrate to you how to use route policies with AS path filters. So scenario number 1, you need to define an AS path filter on R1 to receive only the routes that are originating from 65005. So this is the goal. We only need to receive the routes that are originated from 65005, which means we will only receive one prefix. And that prefix will be 5.5.5.5. All the others will be denied because they are coming from other different autonomous system numbers. So first, when you log into R1, you see that when you display BGP routing table, we are getting all these prefixes. Some are originating from 65002, some are coming from 65003, some are coming from 65004, and then we have the last two that are originating from 65003, 65005, and this is our target. We want to only have these prefixes. All the others should be denied. So we want to receive, so it's a permit. So this is how you specify an AS path filter. You use the command IP and then AS path filter command. You give it a filter name. This is a user defined name. And then you specify the action, either permit or deny. The same way we use for the IP prefixes. Remember that we have two actions, either permit or deny. Permit allows, deny rejects. And then we are specifying that this should be the last autonomous system number in that AS path list. So we'll be applying this AS path filter on both directions, both to router 1 and router 4. If you check from the topology, you will see that we have router 1 connected to router 4 and router 2. So we'll apply that AS path filter to both neighbors. And then we should be able to verify that our AS path filter is working and we are only receiving routes that originated from 65005. So when I go back to this router, again, when you run the routing table, you see that we are having multiple paths or multiple routes coming from different AS numbers. So to avoid deleting the commands manually, I'll use a commit trial. This is a very good trick, especially when you are doing operations in the live network. You can always use the commit trial so that you commit and then you test. If it works, okay. If it doesn't, it will roll back immediately after the specified amount of time that you've configured. So if you are dealing with a delicate network, this is something that you can always do to ensure that if there is the worst case scenario, you've lost connection to the router, the configuration will roll back and then you are able to access it. So you've reduced on the downtime in case there is an issue, a reachability issue to the routers. So you can see that you can always specify this is in seconds. So you can run many times, you can set it to 5 minutes or 10 minutes depending on the testing scenario. But for this case, I'll just use 1 minute. So that will be 60 seconds. And I click enter. Actually, yes, so we've applied the AS path filter. If I now display BGP routing table, you will realize that our routing table now only has the routes that have originated from 65005. All the others, if you sit here, all these ones have been filtered out. Of course, 1.1.1 is local route, so it will be there. But all the others have been filtered out, and we now only have the routes that maybe you don't want. This one will apply in a scenario where you don't want communication from AS 65001 to these other AS. You don't want these prefixes to be advertised to these AS. So you only allow the prefix that needs to be communicated with. So if you need communication from this router, from R1 to R5, you can control the prefixes. You don't have to advertise all these prefixes that are coming from this other autonomous system number to R1. So that is a good scenario that you can use our first application. You are defining an AS path filter on R1 to receive only the routes that are originating from a given AS, and this is how you configure. This one means that will be the last AS in that AS path list, and then you apply it in the import direction. So I hope that is clear. And let's look at scenario 2. So I'm hoping the configurations have already rolled back. You can see that the trial configuration rollback succeeded. And now we can go to our second scenario. Our second scenario, you need to define an AS path filter, filter 2. And that filter 2 will be used to deny the routes that are originating from and permit. Now you want to deny all the routes that are originating from 65,005, but allow the routes that are coming in from the other ASs to be propagated towards R1. Again, if we check the routing table of R1, display BGP routing table, so the configurations have rolled back. You can see that we are getting all this information, even the routes that are originating from 65,005. So the goal is we don't want these two routes to be advertised to R1. These two, the last two that are originated from AS 65005. So we will use this AS number. If this is the last AS, then we stop accepting those routes. And this is what this scenario 2 explains. So you have to define an AS path filter, filter 2, and you see that the action is deny. And we are denying this regular expression. So it will be matching if the route is originated from 65005, deny it. And then we accept everything. Remember, many times, same as IP prefixes, we have the default deny at the end. So if you've denied, you need to permit everything else at the end of that command for it to be okay. So again, we are applying it on the two neighbors. So this is very straightforward. Let's see the impact. So we go to R1 again, apply, commit trial, do a commit trial, and then we do 60 seconds. Commit trial 60, you can do 1 minute. Again, if I rerun the command display BGP routing table, you see that we've filtered out the route that are originating from 65,005. So you can see the power of AS path filter. You can easily control which routes should be advertised where. Which routes from a given autonomous system number should be propagated to which neighbors. So that is the goal of having such an application of AS path filter. So we wait for it to roll back again after 60 seconds, which will be almost over. And once you've achieved this, the third scenario is you need to define an AS path filter, filter 3, to deny the routes that pass through a 65004. So if you go back to our topology, you see that we have routes. We are establishing a BGP session with this 65004. So we want to deny all the routes that are traversing this 65004, and this is how we achieve that functionality. If you go to scenario 3, you can see that you are specifying any AS that is coming in with a 65004. Of course, if you look at R1, so the configurations have rolled back again. 65004, you will see that we are having multiple AS paths that are coming in with 65004. So what we do, we go ahead and let me check my configurations. So I'll copy this. We want to deny all the routes that pass through a 65004 and allow everything else. commit trial. So we'll do a commit trial 1 minute. Then we can check the display BGP routing table again. So you will see that we've denied all the routes that are coming in with 65004. So any route coming in with the AS number 65004 will be denied on this router. And you can see that goal has been achieved by configuring this AS path filter of deny, and then you permit everything else. And then you bind it to the peering session that you want to control. So that one, task completed. The second last scenario, scenario 4, is you need to define an AS path filter to permit locally originated routes and deny routes from other AS. So in some scenario, maybe you don't want to receive any external BGP routes. This is an internal network. You don't want it to learn of any external routes coming in from these autonomous system numbers. Very easy to achieve that. You define an AS path filter, and this should be the case. So it's not having any AS number. Remember, when the routes are advertised from an eBGP, that's when they come in with an AS number or the AS path attached. So when I do this, again, if you check, I hope the configuration have rolled back. If you display IP routing table, we are back to the default where we are learning all the routes. I'll apply this commit trial. I do 60, and then we can check the routing table again. When you check the routing table, you see that we only have the locally originated route in the BGP routing table. All these other routes that are coming in from the external autonomous system numbers have been filtered by our regular expression, which has been configured using the AS path filter. So that one meets the objective, and again, you can use it if you don't want any external routes from other autonomous system number to be advertised to our internal network. And finally, the last scenario is you need to define an AS path filter denying the passing of routes carrying AS 65003 on R4. So we don't want router R4 to advertise any routes to R1 that are carrying these AS 65003. So we define our AS path filter, again, deny as the first statement, and then permitting everything else, and we apply our AS path filter. So I'll copy this, but again, we can verify the routing table before we complete this task. So the configuration of rollback, let me see, display BGP routing table. We expect to have all the routing information. You see that we are getting all the routing information. Remember, this is 10.10.10. So you see that in this one, we have 65004 that is coming in. We are getting it from 65004. If you check the other routes, we are also getting them from 65004. So when I apply these configurations, let me copy them again. We are denying the route that are carrying a 65003. So if it has 65003, we don't advertise it from R4 towards R1. So we only expect to have this one prefix coming in from 20.20.20.1, any route that is traversing 65003. So again, I need to copy the commands again and paste. Let me see. The current configuration has been changed by system. Let's see what's up. I display current configuration. So we don't have the prefixes. Let me apply these. Oh, we need to be on the right router. This is 60. this is for 65004. We were on the wrong router. So we'll apply this. Again, go back to R1 and display BGP routing table. You will see that we have the routing information. Now on R4, I will commit trial. So I hope you will adopt this trick of committing for some few minutes and then you can roll back automatically. So when you display now, you will see that we have less routes, and these less routes, see that we have 1 2 3 4 5 6. We had 1 2 3 4 5 6 7. So we are now not receiving the routes. You see here we had 2, we are now only getting 1 from R2. We are not getting the route from R4. Again, for 4.4.4, this one we expect to get 2 because it's not passing through 65003. If you get any other route, for example 3.3.3, it's coming in from 65003, we filter it out. So we only remain with one route that is coming from 65002. So I hope this is clear. I hope you've seen the value of using ASPath filter and what it can do for your network, especially in controlling how routes are advertised from one part of the network to the other external network. So you can use it both for import and export, and it will do some magic for your network, especially when you are controlling the traffic flow from different sections of the external network. So if you want to have that control of how routes are propagated in your network between different autonomous system numbers, then you can try to use the ASPath filters and it will do magic for your network. So thank you so much for watching this session. Again, just a kind reminder that please support our channel by subscribing to it. Also remember to like, comment, and share this video with your connections. Thank you so much and see you in the next episode.